After graduating from college, Carlos receives two different job offers. Both pay a starting salary of $62,000 per year, but one job promises a $3,720 raise per year, while the other guarantees a 5% raise each year. We can model the annual salary using a linear equation when we have a constant rate of change, which in this case would be when the raise is $3,720 per year, and we can model the annual salary using an exponential equation when we have a percent of growth per year, which in this case is when the raise is 5% each year. So let's first write the equation for the linear growth in the form of y equals b plus mx, which is equivalent to y equals mx plus b, where b is the initial or starting amount and m is the constant rate of change. So for the linear growth, b is the starting salary of $62,000, and m, the constant rate of change, is the raise of $3,720 per year, and therefore m is 3,720. So for the linear growth, we have the equation y equals b plus mx. Instead of x, though, we will use the variable t, since we're told t is time in years. So we have y equals 62,000 plus 3,720t. We'll use this equation to complete the first table, where the salary increases by the constant rate of $3,720 per year. So this table is linear growth. The second table, where the salary increases by 5% per year, is exponential growth. And now let's write the exponential equation, which will be in the form y equals a times b to the power of x. And because we have growth, the base b is equal to 1 plus r, where r is the percent growth as a decimal, and a is the initial or starting amount. So notice how for the exponential equation, a is the initial or starting amount, and for the linear growth, b is the initial or starting amount. So for exponential growth, a is equal to the starting salary of 62,000, and r, the percent growth, is 5% per year, so r is 5%, which is a decimal is 0.05. Because we have growth, the base b is equal to 1 plus r. If we had decay, the base b would be 1 minus r. So in our case, the base b is equal to 1 plus 0.05, which is equal to 1.05, which means when the raise is 5% per year, the annual salary y is equal to 62,000 times 1.05 raised to the power of t. Again, we're using the variable t instead of x. And now let's complete the table for linear growth. The first value of t is 1, and therefore we substitute 1 for t. Using the T84, we could use a table feature, but we'll go ahead and just use the home screen. And therefore we enter 62,000 plus 3,720 times 1, enter. After 1 year, the salary is $65,720. Let's go ahead and record this. Next we have t equals 5. To save time, we can press second enter, which brings up the previous entry, and then we can just change the 1 to a 5 by using the left arrow and overriding the 1 by pressing 5 and then enter. Next we have t equals 10. We can press second enter, change the 5 to a 10, enter, and then we have t equals 15 and t equals 20. Second enter, change the 10 to a 15, enter, second enter, and change the 15 to 20. And let's go ahead and complete the table by recording the salary for t equals 5, 10, 15, and 20. Now we'll complete the table for exponential growth using the equation y equals 62,000 times 1.05 raised to the power of t. The first value of t is 1. We enter 62,000 times 1.05 raised to the power of 1, enter. And let's go ahead and record this, 65,100. For the rest of the table, we need to be where we are told to round to the nearest dollar. To save time, we can press second enter, place the cursor in the exponent position and change the 1 to a 5. And then press enter. Because we have a 4 in the 10th place value, we round down to $79,129. Press second enter and change the exponent to 10, then 15, then 20. Notice how when t is equal to 10, we will round down because we have a 4 in the 10th place value to $100,991. When t is equal to 15, we are going to round up because of the 5 in the 10th place value. We round up to $128,894. And then when t is 20, we round down to $164,504. Let's go ahead and record this. Before we go though, looking at the table, notice how in the short run, the salary is higher when the raise is $3,720 per year, but then in the long run, the salary is higher when the raise is 5% per year. Before we go, let's look at this graphically. The linear growth is the red line, the exponential growth is the blue curve. So notice how it looks like from year 0 to year 8, the red line is above the blue curve, which is why the salary is higher during those years when the raise is $3,720 per year. But then after year 8, the blue curve is above the red line, which is why the annual salary is higher during those years when the raise is 5% per year. I hope you found this helpful.